problem. And so, for example, when I'm looking at this description, it says a landscape artist plans to plant flowers within 2 concentric circles. So again, if maybe some words you may have like forgotten the definition, you can always again like just Google it, right? You don't even need to worry about searching it somewhere in a book. You can always like literally Google the words, because concentric means that the 2 circles have the same center. And then they said here they are concentric circles around a vertical light pole. So the vertical pole is this one here going upwards. And then it says here, R is a point on the inner circle. So R is a point on the inner circle there. So let me just put that in green. Where's this thing here? Green. And then it says S is a point on the outer circle. So the outer circle is like somewhere there. And then it says here, R, Q, and S lie in the same horizontal plane. So all these points, R, Q, and S, they're like on the ground, like on the flat surface. And then it says RS is a pipe used for irrigation system in the garden. So RS is a pipe. RS is a pipe used for irrigation in the garden. So the funny thing is, I think this is also one of the questions in the trigonometry course. So it's not a coincidence that this question keeps popping up, everywhere, low key. It's not a coincidence. The reason why it's not a coincidence is because if someone is going to be like compiling something, right, there is no ways they're going to leave out questions like these, because these are, some of the slightly difficult questions that are worth asking, or they may look difficult, but they're actually like not. So for example, here they say the radius of the inner circle is R units. So already the radius here is like R units, right? And then they say the radius of the outer circle is like QS. So we have QS over there. We can give like a different color, green. So all this being said, they said here we have the angle of elevation from S to P is 30. So angle of elevation is 30. And then it says here RQS is 2x. So this distance here is 2x. Perfect. So that is 2x, right? Now the big idea is that PQ here is square root of 3r. So all this information we've read, it was just reading. We don't need to overthink it really, because there's really no reason. It was just information being given. So the first question they're asking here, show that QS is 3r. So all you do is, any question they ask, whether they're asking for an angle or a side, always identify which triangle you are working in. You see, that's the first thing I can say with these kinds of questions. You see, identify the triangle you are working in. You see, identify the triangle you're working in. So the triangle we're working in, if you're thinking of QS, you can just draw it out for yourself, so that the moment you draw it out, you almost zone out a bit, just a bit. So QS is in 2 triangles. You see, identify the triangle you're working in. So in terms of identifying the triangle, let's actually say triangles like that, so that we end up choosing one, because you don't always work with both of them at the same time. You can work with one, get some information, and then use that information for like the other one. For example, you have 2 triangles where QS is in. So you want to draw those 2 triangles individually, because you won't ever work with all of them, just like randomly or whatever. No. So the one at the bottom, there is QS here. Once we've drawn this one, the only issue is there's R here. Yes, fine. And there's then also, what else do we have here? We have R there, and then here there's 2x. So it's only 2 pieces of information. So normally anything with just 2 pieces of information is a red flag, So you at least need something with 3 pieces of information. It could be 2 sides and an angle, 2 angles and a side, 3 angles or 3 sides, it doesn't matter, as long as you at least have 3 pieces of information. Because if you have 2, that's a red flag, you see. 2 pieces of info is a red flag, you know. There we go. So that's not going to work out, this triangle at the bottom. So we have to look at the other triangle now, the one that's standing upright here, the one that is PQS. So PQS, this one has one piece of information there, which is a 90-degree angle. And then we have another piece of information here, which is this 30-degree angle. So let's do this here, 30 degrees. And then lastly, we have square root of 3r. Square root of 3 with r over there. Now, the big idea with everything that we are doing here is that you can already see this one at least has three things. The 90-degree angle there counts. You see, there's an angle here, angle there, and then side there. So this one is definitely a green flag, you see. So we can definitely use this triangle here. So you see, we've identified the triangle we're working in, because that automatically simplifies everything. Because now we can just remember, okay, fine, we need QS, right? So QS, if this is a right angle triangle, QS is just the adjacent. Yeah, so now we know we have adjacent and opposite. So that's going to be tan, you see. Tan angle S is opposite over adjacent. You see, and then now we can put in the values in there in this calculation. You see, 10 angle 30. PQ is like square root of 3 with R, and then QS is just QS. Now, if you want to solve for QS, we'll obviously have to like cross multiply first. When I say cross multiply first, I'm referring to, for example, this is over 1, right? If you cross multiply, you're going to have the QS with 10, 30, square root of 3 with R. And then dividing both sides by 10, 30, you're going to have QS is equal to square root of 3R, and then 10, 30, you see. And then the QS, you can just put it into your calculator, or rather, yeah, let's see, what is 1030? I think 1030 is, wow, what is 1030 again? Forgot. Let's just use the special triangles. 1, 2, square root of 3. 1030 is square root of 3. So this is going to be quite awkward. 3R, what? Opposite over, oh yes, this is going to be square root of 3 with R, right? Over 1 over square root of 3. Now, if you're dividing with a fraction, you can always tip and multiply, you see. So you're going to multiply this flipped over. So this is going to give you 3R. Do you see it?
Wait.
Yeah, no, take your time.
For the 1030, right?
Yeah, that's the part at the bottom here.
So you're saying we should use the special triangle?
No, if you used your calculator, it was fine. It was still going to be fine. Because the calculator would then just give you square root of 3 over 3, which is still just equivalent to this number.
Okay. I think, okay, let's go back to the diagram. There's just one thing I would like to ask. So how do you like differentiate the planes? Like which plane is the horizontal, which plane is the vertical? Yeah.
Okay, so your description is going to give you that information. For example, here, they said R, Q, S lie in the same horizontal plane. So when they say R, Q, and S lie on the same horizontal plane, then you already know that RQS is like on the ground, you see. Now, this 90-degree angle here, you can already see, you want to always keep your question as the reference point, because it's a real life scenario here where you see here, they're talking about a vertical light pole and then the horizontal plane. Because remember, a vertical light pole will always be on a horizontal plane. You see, like this circle is the ground, and then this pole here is the one going upwards. Hence why this angle is 90 degrees, you see. So if you have something like this going to, if you have R, if you have Q here, right? And then this is like, wait, no, let me not do it like this. Let me just do this. If you have R here, right? And then you also have like S somewhere out there. And then you have this like this. And then they told you that this is 90. Already you know that this is the vertical pole. You see, it's going upwards because of the words here, vertical pole. And then the QRS, horizontal plane. So you know this is like on the ground. So you'll now know that this is one triangle, and then the one here is going to be another triangle, and then the one this side is going to be another triangle. And then the one in front, P, R, and S, that's another triangle also. You see, where there's like a big angle here, and then there's like an angle somewhere there, there's like an angle somewhere there, just in case they ever need you to like work with that specific triangle, you see. So there are like 4 triangles in this image, you see.
Yeah.
You get?
Yeah, boy.
Fantastic, fantastic, fantastic. So that's how you're going to identify which triangles, which one, so that you don't end up like mixing them and thinking that they're together and everything. So for example, with something like 3.2, right, determine in terms of R the area of the flower garden. So the flower garden, you see here, they said a landscape artist plans to plant flowers within 2 concentric circles. So within them, so inside these 2 circles, they want to plant the plants. Then they said here, 2 concentric circles, a vertical light pole, R is a point on the inner circle. And then it says here, this lies on the outer circle, blah, blah, blah. And then it says here, the SR is a pipe used for irrigation. And then it says the radius of the inner circle is that much, blah, blah, blah. So the area of the flower garden. So the flower garden, you want to be careful here because you have to also consider what you have just worked out. You see, we have just worked out QS here, you see. So it has given us the radius over there. Now, here they said this person wants to plant flowers within 2 concentric circles. So they want to plant them in the 2 circles. So meaning the entire garden is here. You have the big circle, which is part of the garden, and then you have the small one, which is also part of the garden, you see. So if they're asking for the area of the garden, you should be considering the big circle. And to help you, you know, even also cement why you'll be using the big circle is just look at what they asked here. They spoke about QS. Now with questions that you answer in math, you don't want to think that they're asking them randomly or it's a coincidence or anything. Whatever they'll ask you, there's a specific reason why they want you to like work that out. You get? Yeah. So with this question here, we have a full circle that we're working with, right? Let me actually copy this so that we don't have to keep scrolling up, down, all the time. You know, we can just keep it down here. So with the question that they asked us now, right? Let me crop this out. We need to remember that our full circle has a formula, you see. The area of a circle is just pi r squared, right? Yeah. And then the big circle, the thing that should comfort us is that our answer needs to be in terms of R anyways. So we don't have to worry about having specific numbers. That's the other big thing with 2D and 3D triangles. Never worry about having actual figures. Just use what you will have in your sketch. Just like this triangle here. We were just using exactly what we had. You see, there's an R there. So we were just using it like that. Here in this circle, right? Our big circle there. The radius is 3R. We worked it out. So that's what you're going to use for the radius, you see. You're just going to throw 3R there. And then your area, in terms of R, is just going to be 9 pi R squared. Because 3 squared is 9, R squared is R squared. And then the 9 times the pi will just give you 9 pi there. You see? Is that okay?
Yeah.
Dope. So
are we saying that QS is our QR? Okay, yeah. The QS, right, becomes our radius,
yeah, because it's the
right?
center from the point there,
The
the point from the circle to the edge there. Because if the description will always help us if we're lost. Because remember they said here the radius of the outer circle is QS. The big issue with most maths is that the description is only read once, which is wrong. You know, the description should be read as many times as you feel you need to read it, like legit. There are times where you'll see, if we're ever going to work on a question and we maybe get stuck, the one thing you'll always see me do is to go back to the description and just like read it over and over and over until like something kind of clicks, you see. Yeah. So with everything that we have said now, the next question, let's see. The next question is asking us to show that RS is this. So these are some of the questions that can easily throw a person off just because of what they're asking. So, I mean, I know in terms of words, right, it may sound like it's easy for us to just say, don't judge the question, don't judge the question. But then that's literally all you need to start doing. Like, don't judge it yet until you've started. And in terms of starting, don't overthink anything. For example, here they're saying show that RS. So before you even read what they want you to show, you just want to focus on what RS is anyways, you see. And then we said, depending on the line that they're talking about, identify which triangle it's in. You see, like in the beginning here, we literally said, yeah, identify the triangle you are working in. So RS, before we even worry about what they're talking about, I'm like, we just need to identify which triangle RS is going to be in. Even though RS is in 2 triangles, I mean, like the only one that's relevant is the one down here. You see, where we have R here and we have 3R over there. You get. And then we also have 2x. You see, 3 pieces of information. Like we said here, the reason why this one was a red flag is because there's only 2 pieces of information. We need at least 3 pieces of information. Cool. Yeah. So we need at least 3. So that's why here, if you look nicely, right, we have 3 pieces of information. And if we need RS, this is where, again, our study guide somewhat comes into play. Because from what's written here, you're always reminded of the fact that with your 2D triangles, if you're going to use the sine rule or the cosine rule, it's always a matter of seeing which information you have been given, you see. So for example, with specifically the cosine rule, what we already know is that for us to use the cosine rule, we need to at least have 2 lines given. It has to be 2 sides. You see here, 2 sides and an included angle. Also, if maybe we have like 3 sides given. So already over time, you'll always be able to recognize that if you're ever going to use the cosine rule, as long as you don't have 2 sides given, you won't even consider it at all, you see. So that's the indicator that you need at least 2 sides given and an included angle. You see the included part is even highlighted because if the angle is not there, you still can't use this. Here, if it's 3 sides given, then it's fine. You will have an unknown angle anyway. So that's why you'll want to use the cosine rule. Now, the big idea here is this is also highlighting why we always need at least 3 pieces of information. Because if you look everywhere here, 1, 2 pieces of information plus 1, that's 3. 2 plus 1, that's 3. 2 plus 1, that's 3. 3 sides, that's 3 pieces of information. So it's the reason why we said that the moment we saw that this only had 2 pieces of information, we just disregarded it immediately. So that's why here our triangle, it has 3 pieces of information, right? So it's like automatically like, you know, it qualifies for us to use it. Because now we can see that we have 2 sides and an included angle. The angle has to be in the middle here. you know, and 99% of the time it will be in the middle there, and otherwise your question won't work out. Remember, they'll have to give you a question that works out. They can't ask a random question that does not a way that it can be solved, you see. So that's why here, if you're looking at what we have, right, the cosine rule here is going to be a minus 2ac, not bc actually. So this is gonna be like 2bc cos a, like that. Do you see it?
Yeah.
Perfect, perfect. So anyways, with all that we have written down here, we need to be careful, right? So in terms of us being careful, know that we're gonna have here a squared is equal to b squared plus, no, we have to put in information now. So here the big idea is always pair the side here with the angle there. You see, as long as you can do that, then you will always be fine. You see.
Okay.
So for example, we have here, what is this? What do we have there? We have, what do we have? We have what you may call the angle here, right, is gonna go for a, the side here is gonna go for rs. So here rs squared, and then the b squared here, what is b now? B is r, c is like 3r, right? And then what you may call 2 with the r here, and then 3r over there, and then this is gonna be like cos angle a is like 2x, like that. So is this clear so far?
Okay. So you say, are we
Pardon?
okay? Like, how do you know? Oh, okay, so that at, okay, let me just put it like this. So at all times, right? Our, let's just say we will substitute our a squared with the value we are looking for. Is that like how are we gonna like do it? Like maybe in like every like paper
No,
or every,
not really, not really. No,
so you
the
can
a
choose that.
just goes with this angle. No, you don't choose. You just have to remember that the angle here will always go with this side. So as long as you
Yeah.
can put these two, the rest will go inside, you see. So already you know that your angle here is always going to go with the opposite side. So that's why the angle here will go with this side, you see. That's why here you're seeing rs, and here you're seeing the angle 2x. Those are the only things you look for. The rest will just be 2, you see. Because for example, sometimes if you had, say, let's have an example, right? If you had, let's say, a triangle, right? And then that triangle has let's say like q r s. No, let's use different variables just so that we can be using like a different example, right? So there's a here, b here, c here. Now if you have, let's say, this angle, right, let's say it's like 2x, and then you have this side here, let's say this is like 3, and then let's say this is like 5, you see. So the only issue here is they can ask for AB, you see. If they ask for AB, you have to remember that according to your formula, right, these two are the ones that go on the edge. You see, so A squared is equal to B squared plus C squared minus 2BC cos A. Something like this, we just have to use this formula as like placeholders. Meaning if you look, you see the A here always goes with that angle. So it's always going to be the pair that's like opposite each other. The angle that you're given, always consider the side opposite it so that you know what to put there. So here automatically you'll be able to put a 3, And then here automatically, you know, you're gonna put the 2x, you see. You don't even have to do it like that. You can just remember to put the 3 first. Because the moment you put the 3, you know that these are the ones that go for B and C. So here you'll put a 5. Here you'll put a missing angle. Let's just put an x there. And then here you'll have here 2 times 5 with the x there. And then cos with the 2x, like that. You see? Perfect. So this is 9 equal to 25 plus x squared. And then you'll be able to carry on. But then for our example, I mean, like we were just showing this as an example, remember? Yeah, so that's fine. Let's just remove it and carry on with the question that we were working with. So with the question that we were working with, right, we have here the following. It says there rs squared. So rs squared is, we don't know. That's what we're looking at, rs squared. And then r, what is r? R is rq. No, there's r there. What am I doing? Oh, no, I already put in everything. We just simplify now. I don't know, I was getting confused. So we can just simplify here now. R squared is r squared, and then this is like 9r squared. Negative 2 times 3 is going to give us negative 6r squared. Okay. And then from here, we have to be careful. Here, it looks like we can just maybe even compare. Here, it looks like there's going to be an r outside somewhere. So let's take out r as a common factor. R squared goes out. We're going to have 1 plus 9 minus 6 cos 2x. Do you see? Yeah. So from here, this is just going to be r squared 10 minus 6 cos 2x. And then at this point in time, you can always be pausing and checking what your expression looks like. So if you go back here, there's a 6 already, fine, there's a 10 already. I mean, that's when you know you're done, you know, because here the next thing is to just square root here, square root there. And this is going to be s, you see. So the square root of, remember, these are being multiplied together, this big bracket and the r squared. So the square root goes for the r squared, which is going to give you r. And then the square root goes for this, which is going to be square root of 10 minus 6 cos 2x, like that. Yeah. So that's the idea with this specific question. Now, obviously, with everything that we have done here, we just need to keep in mind that we would not want to think that anything is like too far-fetched, you know. Wait, what did we get for the area of this thing? We got 9.
What question? Yeah, 9.
Oh, that's for the big one. Okay, yeah, but let's double check here. They said the landscape artist plans to plant flowers within. Okay, so I think here we have to reconsider the within part, because if it's within 2 concentric circles, they're going to refer to this, meaning
Only.
For us to get the area, we can say the big circle minus the small. No, within 2 concentric circles. Oh yeah, I guess this question is a bit weird. But then wait, if it's within 2 concentric circles, then the area of the garden is actually, hold on, let me just show you quickly. We'll just read the question again, so to justify why we're saying what we're saying. So this is the area that they're going to plant the flowers. And we can read the question again, just clarify. The question says, a landscape plans to plant flowers within 2 concentric circles around a vertical pole. And then it says RP is the point on the inner circle, and S is the point on the outer circle. And it says S lies in the horizontal plane, S, R, and Q lie in the same horizontal plane. RS is a pipe used for the irrigation in the garden. So if RS is used for irrigation in the garden, then we need to keep in mind that the portion that's going to be planted is because here it says in two concentric circles. Because it doesn't make sense that this question is talking about two circles, but then the area of the garden is the whole thing. But then the other thing we can also consider is the irrigation pipe here. PRS is a pipe used for the irrigation. So RS is the pipe going from there to there. Do you see that this pipe used for irrigation is a pipe that's between the small circle and the big one? Because you see R is on the small circle, S is on the big circle. So if that pipe is going to be used to irrigate the garden, then it means the garden is this part here, because that's the part where your irrigation system is going to be watering anyways. You see that?
Yeah.
Yeah. So I think with these kinds of questions also, you don't want to maybe dread them and say, wait, I hope this does not come out, because what if I maybe made the mistake and I didn't see that the was the green part? Like, that's not necessarily what you want to be thinking when you're going into an exam, because again, this is one of those really, not like really strange examples. It's just, you know, it's just a bit weird. But then already, because we're doing it as an example, it's always going to example help you to like keep an eye out for these kinds of questions. Because for now, we got 9 pi r for the big one, fine. Now we can just get the area of the small one. The area of the small one, the radius is just r, right? Now the area of that is just going to be pi r squared, right? Of which r is just r. So this is the area of the small one. This is the area of the big one. So the area of the flower garden, so let's even write here, flower garden is going to be equal to 9 pi r squared minus pi r squared, which is going to give us 8 pi r squared. You see? Nice, nice. Anyways. So that's that for that flower garden question, and that's that for this 3.3 question. And then obviously the other thing is, if you look at what we did, right, from like the study guide itself, right, like in terms of how this was worked out, it's literally low-key just like what we did, you see, because we have there like 10, 30 and everything like that. You see here 10, 30, we worked it out, eventually got 3 pi. And then for the two areas, you have here the area of the garden, right, where it's obviously going to be the big one minus the small one, which is the 8 pi over there. And then with the 3.3, already here we're seeing which triangle we're supposed to like work in, you see. Because we're never gonna work with like just random stuff. So for 3.4, where they were asking us for like the actual value of whatever they're asking for, I think let's see what the next question is asking for. The next question is asking specifically for RS. If R was, I think, a 10, maybe they gave us the 10. Let's see what that follow-up question is look like up here. Yeah, so they'd given us R as 10, and then they'd also given another dimension, which is X. So I mean, like, this one is a straightforward question, right? We know that all we need to do is wherever X is, we're gonna throw 56, where R is gonna throw it into this question. So maybe we were not able to prove it for some odd reason. You can still just use the expression, just get marks. You know? So my 6 here, course, X is 56, and then here, let's see what is this in the calculator? It's like 34.99, which is approximately 35 meters. If we're working in meters, because the 10 is given in meters there. Do you see?
I think I made a mistake. Okay, what's your answer? What did I do wrong? It's PR time. 10 minus 6 cos 256. I don't know where I'm making my mistake when punching in here. Because I tried.
Okay, what did you put in the calculator? You put 10 and then square root and then in brackets. Well, the whole thing here has to be in brackets.
Where the 10 minus whatever.
I think maybe I forgot the brackets. Yeah, put everything in brackets.
Okay.
And that's what I forgot to write.
Still, it's giving me this awkward answer.
What answer are you getting?
I'm getting 18,137. I don't know if I'm making a mistake somewhere.
18,137. Okay, let me see something. 10 and then square root symbol. 10 minus 6 cos, and then 2 times 56. Wait a minute, hold on. I'm legit getting a syntax error. So let me see what I did wrong here. 6 cos 2x. So let's see here, times this. Yeah, because when I put what I put in the calculator, it's giving me a syntax error. So let me see what's going on here. Cos 2 times 56, right? This is like negative something. And then 6 times that value. Let's see here. 6 times that value, we're gonna have negative 2 what. And then 10 and that value, we're gonna get that, and then square root of that value, we're gonna get that. And then times 10, wait, hold on. 10 multiplied by square root symbol 10 minus 6 cos 2 times 56. Yeah, I'm getting 34. But let me show you what I put in the calculator. Just switch on this camera thing here so that you can just compare with your side. So in the calculator, you see I put the 10 first, right? Is that what you put?
Yeah.
And then times, and then the square root symbol, and then 10 minus 6 cos, open bracket, and then you close it, and then inside you put it 2 times the 56.
So you know where I think my mistake was? Because when I put it into the calculator, I said I put it, okay, everything was the same, right? I only messed up when I got to the cost. Because I just said
Okay.
10 minus 6, right? Times 2 cos of 56. So yeah, I noticed that mistake.
Yeah. No, I hear you. So no, it's super chilled. Because let's see here. Let's see. Yeah, so that's that with this specific question. There's really nothing more to say about it. So stop this thing here. So I think with